Good morning, y'all. I hope things are going fantastic. I hope the quiz was just great. I am currently sitting in my dining room, recording this video. My chickens were going insane earlier, so if you hear chicken clucking in the background, everything's fine. I can see them. They're safe. Okay, so today what you're going to be doing, so you just took a quiz on discrete, continuous, discontinuous, linear, and exponential, which, like I said, I hope was not too difficult, and I hope you explained everything thoroughly. That was the big thing on that quiz. Anyway, so what we're going to talk about now, you guys are going to work through Module 2.6, and this is kind of bringing everything together. So next class, what we're going to do is review, kind of talk about all of like what is a linear equation, what's an exponential equation, and y'all know this stuff, you know it. What's a point-slope form of an equation? What's a slope-intercept form of equation? Again, you know all that stuff. So we'll review next class, and then we'll have a test on this stuff on Friday. So that's where we're at. That's what the HAPs are. I'm super excited because you guys are good at math. So it's going to be great. Okay. So I am right at the beginning of 2.6. The first page of Module 2.6, the task was all like the list of all the equations, the types of equations, and the name of all the equations. So I'm just on the very next page where they're kind of telling you exactly what they want you to do. So that is where I am at. So I'm going to wait for you to go ahead and get there. I hope you're there. If you need to pause it and get there, do that. Okay, I'm going to keep on talking. Here we go. So I'm just going to read this little paragraph right here. Knowing a number of different forms. I should use my little lightsaber. Hang on. Womp. Okay. Knowing a number of different forms for writing and graphing equations is like having a mathematical toolbox. Yay. You can select the tool you need for the job, or in this case, the form of the equation that makes the job easier. Fantastic. So all of that stuff on the last page, all of those equations, those are tools for you to use to make this stuff más fácil, easier. Okay? So any master builder will tell you that the more tools you have, the better. In this task, we'll work with all of our mathematical tools to be sure that we know how to use them all efficiently. As you model the situations in the following problems, and remember, guys, what does that word model mean right there? Does anybody remember that word model? Remember, that means to just write an equation. That's all that means. So equation. Anytime I ask you to mathematically model a situation, it just means you're writing an equation for it. Okay, so as you model the situations in the following problems, think about the important information in the problem and the conclusions that can be drawn from it. Is the function linear or exponential? Those are big words. I'm gonna highlight those words real quick. Linear. I tried to highlight. You see what happened, and it turned out to be still my doo-woppy. Linear or exponential. Ooh. Does the problem give you the slope, a point, a ratio, a y-intercept? We know how to deal with all of those. Is the function discrete or continuous? Okay, I needed to be highlighting like crazy here. Let's use a different color, blue. Discrete, continuous, let's use yellow for this. A slope, a point, a ratio, a y-intercept. What's going on? And remember, folks, I should say this, ratio, remember ratio, that guy is just talking about like a common ratio. So what we would use in a geometric sequence, what we're multiplying by, or I guess an exponential sequence. Okay, so this information helps you to identify the best tools and get to work. Because you're a master builder. Get it? You're getting to work. Okay, cool. So, folks, here's what I had thought. I thought I would just do the first couple with you here. And then just to kind of set you off on the right foot so you know what the heck to do. And then, excuse me, pardon me. Y'all can forge ahead on your own. I will eventually put a key up to this. I don't think I'll have a key up tomorrow because I don't want you to just look at the key and then be like, okay, I'm done. I want you to try it first and then go back and look at the key as you're studying. So I'll probably put up the key on Wednesday. So you have a chance to kind of really explore what this stuff is. But you can check in with either me or Ms. Heisler, and one of us will have the key if you need kind of a jump start to get going. Okay, so let's talk about number one. In his job selling vacuums, hang on, we're going to have a quick picture break so I can draw a vacuum. What do vacuums look like? Back in my day, they look like this. And then there's like this crazy, yeah. And they would have like boop, 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 lights on them. Okay, so Joe is selling vacuums. Fantastic. Good job, Joe. He makes $500 each month plus $20 for each vacuum he sells. Guys, what are the important things in this first sentence? Because there's a lot of information here that we need to know. What is the $500? So he makes $500 each month plus $20 for each vacuum he sells. Before we do that, let's see what we're trying to actually do. Write the equation that describes Joe's monthly income, I, as a function of the N, the number of vacuums sold. Okay, so what is the $500? If we're looking at just monthly income, the $500, he gets that no matter what, right? So that is going to be, I think, our starting value, right? So I'm going to say start value is $500. Booyah, $500. And then what's this $20 business over here, this 20 bucks right here, plus 20 bucks for each vacuum he sells. This word right here, plus, that's kind of a big deal. What is that telling me? I'm adding $20. So what kind of sequence is this going to be, do you think? If you said arithmetic, you are correct. What kind of pattern is that? Is that linear or exponential? If you said linear, I'm just going to assume you did, you are correct. So now, oh my gosh, we know so much information about what kind of equation we need. If I know it's a linear equation, I know I have a start value. What is this plus $20 for each vacuum he sells? It looks like, y'all, that might be the slope. So the slope, no, let's not say the slope. I'm going to change that. Erase. I'm going to call that the rate of change. Let's call it the rate of change. Rate of change, which is the slope. But for our word problem, I think it's easier to call it the rate of change. If you want to write down slope, it is the exact same thing. So you feel free to do that. Okay, so we have a start value, we have a rate of change. It is a linear equation. Y'all, what is the general format for a linear equation? Anyone? That's right, it's y equals mx plus b. Fantastic. Okay, so that means we're going to have y equals my slope, or rate of change, which is 20x, and then my start value, which is b, which is $500. And I wrote that, actually, hang on, I'll tell you why I wrote that, because that's the next question. I'm getting ahead of myself. Name the form of the equation you wrote and why you chose to use that form. So what kind of equation is this? This is a slope-intercept form. Intercept form. And why do we choose to write the slope-intercept form? Why do you think we chose to write the slope-intercept form? I would say probably that we had the slope, or the rate of change, and an intercept, the start value. Because remember, the start value is the same thing as the y-intercept. So since we had the slope and the intercept, that's why I chose the slope-intercept form. Make sense? I hope so. So I'm going to say, because I have the slope and intercept. Huzzah! Okay, now this function is linear or exponential. It is linear. Boom, 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 boom. This function is continuous, discrete, or neither. Interesting. Y'all, let's think. I'm just gonna do this real quick. Whoa, golly. Let's think about what a graph of this would look like real quick. So, oh, not highlighter. Come back. Pencil. So we're looking at income as a function of vacuums. Are there two C's in fact? No. Okay. So he starts at $500, right? So there's $500 right there. Shablam. So even when he has sold 0 vacuums, he's down here at $500. That's my intercept, right? That's when I cross the y-axis. Then every time he goes forward, he increases by $20. So let's just say, I'm going to zoom into this graph real quick. Whoa. Let's just say that instead of starting at 0, we started at $480 because I want my scale, remember, I want my scale to be consistent. I don't want to like say like, oh, this part is worth $500, but this part is only worth $20. I want the scale to be consistent all the way up. So I'm going to make each one of these worth $20. Okay, so after one vacuum, oops, I should label that part down there. 1, 2, 3, 4, 5. Okay, so after one vacuum, Joe is now at $520. After 2 vacuums, Joe is now at $540, and after 3, he's up at $560. So now we can definitely see that it is a linear equation, right? Because it's making a nice straight line. Now the question is, do we connect these? So let's think about it. Can Joe sell 0.5 of a vacuum? Can he be right in the middle here and be like, oh, I've sold 0.5, so that means I'm at $510? The answer, I think, is probably no. He cannot do that. Now, judging from what we talked about last class, you might think that this is a discontinuous function because you might say, oh, well, Joe could like have $500 and then jump up, like do this and then jump right up to $520 and then keep $520 and jump up to $540 and so on and so forth. If you want to say that, as long as you explain it, that is so cool. If you say that it is discrete because they don't connect, I would also take that, like I said, as long as you give me a good explanation. So all of this is about explanation. I think I like the discontinuous option. Oh my golly, that's not, I am just all over the place. I think I like the discontinuous option. And let's get to a pen. Discontinuous. Because that makes sense to me looking at the graph that he would have $500 until he sold the next one, and then he would have $520 until he sold the next one, and so on and so forth. So that would make sense to me. If you chose discrete, I keep forgetting to change to highlighter. If you chose discrete, I think that's fine. I would probably want you to have an explanation. Now, the good news is, y'all, on the test on Friday, you were probably not going to have a whole lot of questions about discrete and continuous because that was what you were just tested on. So I would say a maximum of like 1 or 2 questions about discrete and continuous on the big test on Friday. So it's important for you to know, but don't like super stress out about it. Okay, that is number 1. I'm going to do number 2 really quickly, and then I'm going to call it a day, and well, I'm going to call it a morning, and let you guys finish the rest of this on your own. Okay, so let's go to number 2. Okay, so here we are for number 2. Write the equation of the line with a slope of -1 through the point -2, 5. Y'all, do you see what we have? We have a slope and we have a point. What does that sound like? If you said point slope form, you're exactly correct. So I think we should probably use point slope form to write this equation, to write our model for this situation. So hooray, we've already answered this question. Name the form of the equation you wrote and why you chose to use that form. Y'all, we chose point slope form, and we chose that because we have the slope and we have a point. Easy. Okay, so who remembers what point slope form actually is? Hopefully you have it memorized. If you don't have it memorized, memorize it. Write it down 20 times or something and see if you can get it memorized. So it is y equals m times x minus x sub 1 plus y sub 1. And that is given a point, not y. erase that, erase, given a point x sub 1 comma y sub 1. So I am going to look right up yonder at my point, and I'm going to say, hey, Mr. Point, you must be the x, you must be the y. So x sub 1, y sub 1, and then we already know our slope right there, so our equation is going to be y equals negative 1 times x minus, what's my x sub 1 value? That's a negative 2, and then plus 5. Oi, y'all, what happens when we have a negative and a negative right next to each other? Anybody know? Anybody? If you are telling me it changes to a plus, you are so correct. So it changes just to a big fat plus. So this is going to be negative 1 times x plus 2 plus 5 right there. So that's going to be my final equation. So what kind of function is this? Is this a linear or an exponential function? With point slope form, that is going to be definitely linear. So slope intercept form and point slope form, those are the two kinds of linear equations that we will have, because technically exponential equations don't have slope. Because remember, slope is rise over run. So with a linear equation, let me just zoom in on this over here. Whoa! With a linear equation, I've got my rise going up and my run going over. Rise going up, run going over. Rise going up, run going over. So my slope on a linear equation is constant. Whereas with an exponential equation, if I try to look at the rise over run here, y'all, look what's going to happen. I have rise over run. Then I have rise over run. Then I have rise over. So it's changing, right? It's different every time I go. So I don't have a consistent rise over run. So that means that slope only happens with linear equations, because with exponential equations, the slope is not the same. So I'm not going to say that I have a slope for exponential because it's changing all the time. So I don't have a slope. So, Shablan. Now, is this function continuous, discrete, or neither? Well, let's look back up at the sentence. It has told us we are writing the equation of a line. Y'all, it says line. What do we know about lines when we draw lines? Here's a line. Here's another line. Here's another line. Are these lines continuous, discrete, or neither? What do you think? If you were telling me continuous, you are exactly correct. And what I will let you know is, I'm going to write this down, so hopefully you will remember it. Anytime you have an equation that makes a continuous function. Makes a continuous function. And the reason why that is because when we have a whole equation, that means I can make a whole line, because I'm like, oh, I have a starting point and I have a slope, so I know what everything is going to be on the equation. And for an equation, anything I plug into this equation, any x and any y, anywhere on that line is going to work. So it's continuous. It's every single point possible. If you have a table, that's not the same. So a table, that would be more discrete because I'm only giving you the points that are on the table. With the equation, I'm giving you a whole model that represents all of these points that fall on this line for the equation. So equation is continuous. Anytime you have an equation, it is continuous. Okay, hopefully that makes a little bit of sense. Rock and roll. What I would love for you to do is turn to your neighbor if they're not still working on the quiz. If they are still working on the quiz, leave them alone. If they aren't still working on the quiz, go ahead and turn to them and let them know what you have just learned about equations being continuous all the time and tables not being continuous all the time. See if they understand that. Maybe check your first couple of answers with each other. Definitely check number 3 with each other so you know that you're on the right track. Okay, guys, you are going to be awesome. Finish this up. And then your homework, after you finish this module, your homework is the ready, set, go at the end of this module. If you finish all that and you're like, Miss Wright, I don't have anything to do, then go back to other homeworks and work on those because those homeworks are really, really helpful as you're getting ready for our assessment, which again is on Friday. Okay, y'all, have a great day. Be nice to each other, and I will see you soon. Okay, bye.